Well, welcome to another RDWorks Learning Lab. Today we plan to carry on where we left off and try and find out a bit more about 3D engraving. But before we start, I'd just like to point out to you my wonderful new t-shirt that my stepdaughter bought for me. Now, I call it my Alzheimer's t-shirt because, and she tells me that she's also got my address label and blood group sewn in the back. Now, I can't imagine why she thinks I'm suffering from Alzheimer's at this early age. Now, we found out last time that working over such a wide range as this caused quite a few problems when we're putting a lot of power in, specifically at the lower speed. So today what I'm going to try and do is to do some of the same tests again, but I'm going to suppress the range over which I work. Technically, I would like to be working above about 14%. Up to 14%. I'm suffering from this high frequency impact engraving, i.e. the pre-ionization phase of the tube. But that takes me up to best part of 22 watts. So that means if I try and stay away from that zone, I've got to set my minimum at 14% and my maximum probably at the end of this linear range, which is going to be 19%. So I'm only going to get 14 to 19%, but I should pick up the whole of this range here. Now that might sound like a good idea, except it does mean to say that when I'm basically calling for white, I shall still be punching a hole with 20 watts, 22 watts. Now that doesn't make any sense at all. Basically, for white, I really need to be close to 0, which is right down here at my 9%, or 2 watts. Now, the problem with working down here is you get non-linearity because of a completely different phenomenon. Now, look at the second, third, fourth and fifth steps. They're all nice and uniform, but this first step is huge. The second step is quite a bit more than probably you would expect, and then they settle down to much smaller increments all the way up and all the way back down, except for that step there and that step there. And you notice how much bigger those two steps are. Well, that's because of this high frequency impact engraving zone, where although basically the average power claims to be, say, 10 watts for this step, because there are huge energy bursts, spikes of energy taking place, you can clearly see that you're getting substantially more than 10 watts worth of energy at these low steps. So that's more than 10 and that's more than 20, and then we go on to 30, 40, 50, 60, 70, and then we drop down here and you can see that at 20 we've got a big step down to 10 and a big step down to nothing. And that's my problem. We're going to get some non-linearity at the lower powers purely because of this pre-ionization zone. I think we've decided that we've got to stick with 9% because that's 2 watts. And how far do I go up the chart? Okay, so we've got our power set at 9 and 22 in the end. And I'm going to set the speed at 50 to start with because that's the optimum speed. Maybe we can go up to 100. We're not trying to bounce off the walls this time. All we're trying to do is basically establish some good parameters for this engraving. I've still got my direct output and I'm still going to be using X swing, and the step interval at the moment I'm going to leave at 0.25, but I may change that later. But we'll leave it at that at the moment, so we've got direct comparisons with what we did on the previous occasion. Now, I don't think there's any doubt that you can hear that squeaky cut. I will just turn the fan off. Now that is a very noisy cut. That tells me that we're working in this pre-ionization zone. We need to go and look at these under the microscope because we've got some nice cuts here and here, but just in the middle where maximum power is, it looks a little bit messy. Let's go and have a look, see what we've done. Well, this is 50 millimeters a second and 100 pixels per inch, and we've got a full set of pixels there by the look of it. Now, as we move towards the center,
We can see some crazy paving appearing on the side wall, indicating that we've actually put a little bit too much heat in there. Let's take a look at it from the other side, from the top side. There we've got a nice set of pixels, and as we run down towards the centre, nice parallel lines, and then all of a sudden when we get towards the centre, probably the last couple of steps, we're starting to break up, and we're getting a bit of a hideous mess here, and that's purely because we've got too much heat into that particular area. And so consequently, here we go back out into the high frequency pre-ionization zone, and we're back to nice dots again. Now, I think the only thing that we can do, we guessed wrong to start with at 22%. I think we're going to have to back this off to something like about 16%.
There is still a hint of that strange marking in the centre there, but I think what we're going to do at the moment is we're not going to go any lower.
Well, here we are at 16%, and we've still got our little spiky gear teeth. And let's turn it over and have a look what's happening going towards the centre. Well, there's just a little teeny weeny bit of fuzziness right in the centre spot itself, but generally it's not bad. So I think we can live with 16%.
Now the focus is currently set to 4mm and it should be 5, so I've already set it just a little bit below the surface. But what I will do is change that to something like, I'm going to take it to 7mm. So that's 2mm out of normal focus, but right at the centre it's going to be probably closer to 3.5mm out of focus.
Here's what 16% looks like when we defocus the beam. Let's have a look at it from the side. And look, there's absolutely no serious peaks there. Little teeny weeny bobbles, but no peaks. So I only needed to drop the work by 2mm to get rid of those peaks. In other words, the out of focus has caused those peaks to disappear. And I've got a fairly uniform surface.
Well, we've done one pass, and now we're just about to start the second pass. It's got a little bit of definition to it already from the first pass. Now I'm going to close the lid because I want the gas to lift up and flow across the job. I don't want it to settle on the job. Now that's not bad for just 2 passes. I can see that I'm never going to get rid of the tartan effect in the background. It's just one of those features that I think is inherent with 3D carving. As I mentioned a year ago when we touched this the first time, even when you look at kerns, they've still got this textured background. So, you know, it's something inherent in the software or the way the algorithms are written. But what I am going to do is I'm going to try something completely different for the next pass. Well, it's 2 passes and it's about 3mm deep, so that's not doing too badly. And I have to say that I'm pretty pleased at the amount of detail that's coming out. I didn't have anywhere near this success the last time I tried this. So I'm doing this with
roughly 30 watts coming out of the tube. So by the time you take away, let's just say 5% for each mirror, 1, 2, 3, and the lens, 5, 4 so 20%. I mean, I'm losing, what, 6 watts? So we've only got 24 watts maximum, down to about 1 watt. So between 1 and 24 watts is carving that job. Okay, now I'm going to change a couple of things. I'm going to change it back to X swing. I'm going to leave the power the same, and I'm going to put the speed up to 200. Hopefully that's going to produce like a polishing cut. Well, that seems to be doing a pretty good job of polishing that up. It's leaving it nice and clean. The background is still a bit dusty, but the actual image itself is coming out beautifully clean. It's amazing what a little bit of understanding can do, isn't it? Now we've got our tapestry background as we had before, but hey, we know what's causing it now, so we're no longer we can't worry about it because we can't fix it. But the rest of the detail there, it's pretty good, isn't it? In fact, as you can see there, that is literally only dust sitting in there. Well, that's amazingly clean, isn't it? Catch a little glimpse of the light behind it, and it really does come out beautifully. Now I have to say, I'm quite proud of that. Now I dug up my experiment from a year ago, and there is no comparison. Now this picture, if we put the bitmap handle around it, we find that it comes in at 343 pixels. Make those go 0. Set output resolution, we'll change that to 100. Apply and apply. Okay. So, we'll just check again. Bitmap handle. And sure enough, it's now 100 pixels per inch. Okay, and I'm going to start down at the bottom left-hand corner. And we're going to use the same parameters, 9 and 16, 50 millimeters a second, and we're going to go for X swing and 0.127, i.e. twice as many scan lines as the resolution. So the scan lines are 200 scans per inch. Okay. Looks like the power is performing about the same as it did on acrylic. In other words, it looks as though we've taken about 2 millimeters deep. So again, it looks as though we should be doing 4 cuts. 2 horizontal cuts, a Y swing cut, and then maybe a 200 finishing cut. Now it looks like a nasty, shiny, tarry residue on the surface there. And I'm wondering whether I've still got too much air assist. So when this cut is finished,
I'm going to adjust the air assist. Don't want to touch anything, so I've got my little container of water there. As you can see, I've still got quite a lot of bubbles coming out of there. So let's just turn that off to reduce the bubbles. In fact, I've got it turned right off now and it's still bubbling nicely. So that's good. I can turn that off and know that I've still got some airflow coming out of the nozzle. No, we won't. We'll have some air. We'll have lots of air. Well, it's well formed, but also well black. So let's just see what happens when we go for a 200 clean-up cut. 200 millimeters a second. Wow, that's interesting. Look at that. Not only does it work on acrylic, it also works on wood. Now, as you can probably see, that looks rather speckled and pitted. So I suspect that some of those very sharp, pointy power pulses have gone in and burnt their way into the wood. Now, whether if I do another one of these cuts it will tidy it up, I don't know, but we might give it a try. That doesn't fix it. Let's go and scrub it with a scrubbing brush. Well, here we are. We've scrubbed both of them up with some soap and water, and we've taken most of the brown off of the one on the right. The one on the left had all sorts of strange lines in it, and some of those lines were vertical lines that I described as coarse hessing. Well, we don't have those same things in here. The technique that we've used now of X and Y, I think, has destroyed that pattern, and what we've got instead are some dots in the background. So overall, I think this is quite a pleasing result. We've discovered a way in which to get reasonable results. 3D carving. Now, there is another feature built into this machine which is supposed to aid things like 3D carving specifically. They don't recommend that you keep it on all the time, but it is a special mode, and it allows you to mess around with something that they call the facula. Now, I think that's the way it's said, but basically I think it's the size of the beam, and I don't know how it works, but I think probably we shall have to look at that in a separate session, because it says it's designed to keep the bottom of deep carvings flat. Now, how it can do that, I don't know, because they're not bad, just a little bit pimply or a little bit liney at the moment. This is a nice piece of white maple, this wood, and the effect that it's come out with, burning dark in the background and light in the foreground, is quite attractive. In fact, it's a much better, cleaner result than what we did a year ago, and I thought it was quite reasonable then, but I'm very pleased with what we've got today. So I hope that we've learnt something, and we've just basically ignored the fact that we are going to get some sort of marking in the background, but provided we set the beam out of focus, it doesn't seem to affect the sensitivity of the engraving very much at all. We're still getting fairly good resolution on these details, as you can see. The Perspex one is absolutely brilliant. Now that Perspex is not normal clear Perspex. If you look on the edge, it's got a greeny look to it, and that's supposed to simulate proper glass. And it has got a sort of a matte finish on it, like a piece of Lalique glass. And overall, I'm extremely pleased with that piece. Well, as I indicated at the beginning of this session, I didn't think we would need to move up into this non-linear part of the curve. And in fact, we've been working between 9%, which is 2 watts, and 16%, which is 30 watts. Now, I think that we could probably even move down here to somewhere in the region of about 12% or 13%. 13% would be good, because that's about 18 watts. So between 2 and 18 watts would probably give us even better results, because we wouldn't get quite such an extreme burn. But basically what I'm saying is, with any sort of engraving, it looks as though we need to be working down here in these very, very low regions, not up here in these 60-70 watts region, because that's for cutting. Engraving appears to be most successful down in this 20, 30, 10 even watts region. Well, I think that's been quite a successful conclusion to our 3D engraving. There's obviously a lot more to learn, there's a lot more experimenting to do, but I think from the information that we've now found, we can proceed and experiment on our own, you and me. So thank you very much for watching, and yeah, I'm going to try and find my own way home now, so I'll see you in the next session, maybe.